Discover the secret behind your favorite dishes. The Maillard reaction explained. Ever wondered what turns a plain piece of meat into a savory delight or gives bread its golden crust? This culinary magic is thanks to the Maillard reaction, a chemical ballet that happens in our kitchens every day. It's not just cooking, it's chemistry in action, transforming our meals into a feast for the senses. Named after French chemist Louis-Camille Maillard, who first described it in 1912, the Maillard reaction occurs when amino acids, the building blocks of proteins, and reducing sugars, simple sugars that can participate in reduction reactions, are exposed to heat. This typically happens during high-heat cooking methods like grilling, roasting, or frying. When these amino acids and sugars are heated, they undergo a complex series of reactions. First, they form a compound called glycosylamine through a process known as condensation. This then rearranges itself into different types of molecules, producing a range of flavors and brown pigments called melanoidins. The Maillard reaction is a form of non-enzymatic browning, different from caramelization, which involves sugars alone. This reaction is responsible for creating hundreds of different flavor compounds. The exact flavor and color depend on the type of amino acids and sugars present, the cooking temperature, and the cooking time. In meats, the Maillard reaction creates the savory, complex flavors we associate with a perfectly grilled steak. The reaction varies in different meats due to their distinct amino acid profiles, contributing to the unique taste of beef, pork, chicken, and other meats. In bread and baked goods, the reaction not only gives a tempting golden brown crust, but also adds toasty, nutty flavors. The presence of yeast or baking powder, which can alter the pH, can also influence the Maillard reaction and the resulting flavor profile. Even in coffee and chocolate, the Maillard reaction plays a crucial role. Roasting coffee beans or cocoa beans triggers this reaction, developing the deep, rich flavors and aromas characteristic of these beloved products. To maximize the Maillard reaction in your cooking, consider the following tips. Dry the surface of foods, as water inhibits browning. Use moderate to high heat to facilitate the reaction, but avoid burning. Flip the food only when it has developed a good sear to ensure even browning. While the Maillard reaction enhances flavor, it's important to balance it with safety. Overcooking, especially at very high temperatures, can lead to the formation of harmful compounds like acrylamide. So, the next time you cook, think about the Maillard reaction. With a bit of heat and science, you're not just making dinner, you're crafting a chemical masterpiece that delights the palate.